Hello and welcome back to e-sipnayan. For today's video, we are going to discuss the second conic section, which is the parabola. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. The learning objectives at the end of this video that hopefully we are going to achieve are the following. First, you should be able to identify the parts of a parabola, then identify the opening of a parabola given the center radius form or standard form. Let me now discuss the basic concepts about a parabola. To start off, we define what a parabola is. And parabola is defined as the set of all points in a plane equidistant from a fixed point called the focus and a fixed line called the directrix. Shown here on the right is an illustration of a parabola, and the fixed point or focus mentioned in the definition pertains to this point, whereas the fixed line mentioned or the directrix pertains to this horizontal green line. So definitely, to explain the definition, we refer to this curve. Say for example, we choose any point and let that point be this point here. And then if we measure the distance between this point and the focus, and that same point to any point perpendicular to the directrix, they should be equal. Those are the key characteristics of a parabola. Aside from the definition of a parabola, I also want to emphasize what a parabola looks like. And for you to be able to effectively remember and keep in mind the illustration of a parabola, you just need to think of one letter, and that is letter U. So the letter U is the figure that best resembles the illustration of a parabola. Let's now talk about the opening of a parabola. And when we say opening, it is also the same as the orientation of the parabola. And there are four. The first opening could be a parabola that opens upward. This one is the same as letter U. We also have an opening that is downward, and this is the same as an inverted U. The third opening is a parabola that opens to the right. If you notice, the opening of the letter U is to the right. This is also similar to a letter U that is rotated 90 degrees to the right. And the last opening is a parabola that opens to the left. And this is also the same as a letter U that is rotated 90 degrees to the right. So these are the four openings of a parabola: upward, downward, opens to the right, and opens to the left. Now that you know the different openings of a parabola and you are familiar with their form, it's now time to discuss the different equations of a parabola. All of the equations that I will be showing to you later on will be in center radius form. So since there are four different openings of a parabola, there are also four center radius form. The first one represents a parabola that opens to the right. Its quantity y minus k squared equals 4p times x minus h. The next one represents a parabola that opens to the left. It's read as quantity y minus k squared equals negative 4p times x minus h. The third one represents a parabola that opens upward. That is quantity x minus h squared equals 4p times y minus k. And last but not least, this is the formula that represents a parabola that opens downward. Its quantity x minus h squared equals negative 4p times y minus k. If you notice, all of the equations are somehow similar in form. On the left-hand side of the equation is either x minus h or y minus k that is squared. On the right-hand side of the equation, you can see there are similar terms such as 4p and either x minus h or y minus k. You already know what the h and k is. But how about the new variable p? P here is called the focal length, and this is simply defined as the distance between the vertex and the focus. Later on, when we discuss the parts of a parabola, we'll be enlightened what that P is all about, what vertex is, and what is focus. Meanwhile, here is the illustration of the different forms of a parabola. Moving on, let me now discuss how to easily identify the orientation or opening of a parabola given the center radius form. I prepared a simple illustration. So we know that all conic sections are quadratic equations. And when we say quadratic equations, these are types of equations wherein the highest degree or exponent is 2. Now, how will you know that a quadratic equation is a parabola? The only thing that you need to look is how many variables are squared. And there should only be one. It's either x is squared or y is squared. Then, after determining which variable is squared, either x or y, you will have a further hint on what the opening will be. So when x is squared, the only possible options of openings will be a parabola that opens downward or upward. However, when y is squared, the options for the openings will be a parabola that opens to the left or a parabola that opens to the right. Now you may ask, how will you determine whether the opening is downward or upward or left or right? You need to consider the sign of 4p. So if it is a parabola that opens downward, 4p should be negative. Hence, for you to determine that a quadratic equation in center radius form is a parabola that opens downward, x should be squared and 4p should be negative. Next, for a parabola to open upward, the center radius form should have x squared and then the symbol for p or the sign for p is positive. Next, for a parabola to open to the left, y should be squared and then the sign of 4p should be negative. And then lastly, for a parabola to open to the right, y should be squared and the sign of 4p is positive. So this is like a summary of illustration on how you can easily identify the openings of a parabola. And I hope this one will help you in the future. Alright, so moving on, let's now try to practice determining the opening of a parabola given the center radius form. This is the first equation. We have quantity x minus 5 squared equals negative 24 quantity y minus 1. Again, the first thing that you need to take note is that which variable is being squared. Is it x or y? And in this first example, we can explicitly see that x is the one that is squared, y is not. Hence, we'll have a hint that this parabola may open upward or downward. And what is the distinguishing factor? You just need to take note of the sign of 4p. In this case, 4p is represented by negative 24. Since 24 is negative, we can now conclude that this center radius form is a parabola that opens downward. Next, we have x minus 1 squared equals 10 times y plus 4. Again, take note which variable is squared. And in this case, x again is squared. So the possible options would be, it may be a parabola that opens upward or downward. Again, you refer to 4p. And 4p here is represented by positive 10. And since 10 is positive, we can conclude that this is a parabola that opens upward. Next, we have quantity y plus 1 squared equals 16 times x minus 1. We notice that in the third example, this time y is squared. Then, you will know that the only possible options would be, it may be a parabola that opens to the left or to the right. We now take note what 4p is. 4p is represented by 16. And since 16 is positive, we can now conclude that this is a parabola that opens to the right. Another example, we have quantity x minus 10 squared equals negative 20 quantity y minus 8. So in this example, x is squared and for p is negative. Therefore, this is a parabola that opens downward. Let's have 4 more examples, but this time let's fast track. So we have quantity y plus 1 squared equals 8 times x minus 5. Y is squared here, and for p is represented by 8, which is positive. Hence, this is a parabola that opens to the right. Next, we have quantity x plus 7 squared equals negative quantity y minus 2. X is the one that is squared here, and our 4p is negative, and if you don't see any number, it is automatically represented as 1. So 4p is negative 1, and since it's negative and x is squared, it's a parabola that opens downward. Second to the last example, we have quantity y minus 6 squared equals negative 12 times x plus 9. Y is squared here, and 4p, represented by negative 12, is negative. Therefore, this is a parabola that opens to the left. And lastly, we have x squared equals 24y. Obviously, x is the one that is squared here. And our 4p is represented by positive 24. Therefore, we can conclude that this is a parabola that opens upward. Now that you know how to determine the opening of a parabola given the center radius form, let me now discuss the parts of a parabola. Here, I will be discussing the essential parts of a parabola that will be needed later on when we graph. The first and the most important part is called the vertex. Vertex is the counterpart of the center in a circle. The next essential part is called the focus. Focus was mentioned a while ago, given the definition of a parabola. Aside from that, we also need to know about the directrix, then the latus rectum. And last part that you need to know before graphing a parabola is the axis of symmetry. Let's now identify or relate these parts given some symbols or measurements. For the vertex, it's similar to a circle and it is represented by coordinates h, k. For the focus, you're going to identify this one using the measurement p or the focal length. For the directrix, it is a line represented by the equation either x equals h or y equals k. And this equation are constant equations. For the latus rectum, its measurement is 4p, or simply 4 times the value of p. So later on, you will be having a numerical value for p, and then you simply multiply it by 4 to get the length of the latus rectum. And last but not least is the axis of symmetry. It is the same as a directrix, and since it is a straight line, then it will be represented by a constant function. So please note that knowing the opening of the parabola will enable you to know the direction of the points when plotting the parts. That's why we started with identifying the orientation or opening of a parabola, because it will be our basis for the movements when we graph the parts of a parabola. Let's now discuss the parts of a parabola, and we start with the most important part, which is the vertex. Vertex is the counterpart of parabola in the center of a circle. This is the illustration of the vertex, and if you notice, it is the downmost part of the curve in this given example. Now, vertex or the vertex of a parabola is defined as the midpoint of the perpendicular segment from the focus to the directrix, or you can simply pertain to it as the highest peak of the curve. Aside from the vertex, we also need to be familiar with the focus, and focus is defined as the fixed point. Now, fixed point is very important in a parabola because this is the one that defines the curve. Aside from the focus, directrix is another part, and it is defined as the fixed line. It goes hand in hand with the focus. This is also an essential part in constructing the curve of a parabola. Now, the next part is called the axis of symmetry, and it is simply defined as the line that passes through the vertex and focus. And here is the illustration. So the vertex is the larger circle here, while the focus is the smaller circle. If you connect the 2 points and extend the line, you can form the axis of symmetry. Kindly take note that the axis of symmetry should always pass through the vertex and the focus. Moving on, let me discuss now latus rectum. Latus rectum is simply defined as the line segment through the focus perpendicular to the axis of symmetry. So the violet horizontal line segment here is the illustration of latus rectum. And if you notice, it passes through the focus and it should always pass through the focus. Let's now try to illustrate the essential parts of a parabola through graphing. In graphing a parabola, we start by plotting the vertex. It will be our starting point and we label it as HK. Now, say for example, we are graphing a parabola that opens upward and that the vertex will be plotted somewhere here along the x-axis. After plotting the vertex, we now proceed in plotting the focus. So the focus will be plotted in a similar direction as the orientation. Now, since we are graphing a parabola that opens upward, to plot the focus, the movement will also be upward. And how many units are we going to move upwards? That will be p units above. So, starting from the vertex, we simply count p units above, then we plot the focus using the symbol capital letter F. After plotting the focus, we are going to plot the directrix, and this time, the movement would be the opposite direction or downward. And how many units are we going to move downwards? The same as the focus, that will be p units below. So starting from the vertex, we count p units below, and then simply draw a horizontal line. The green line you're seeing now here is called the directrix. So if you notice, the measurement between V or the vertex and the focus is the same as the distance between the vertex and a point here in the directrix. After plotting the directrix, the next goal is to graph or plot the endpoints of the latus rectum. So in plotting the endpoints of the latus rectum in a parabola that opens upward, the movement will be to the left and to the right, but this time we are not anymore starting from the vertex but rather the focus, because latus rectum is defined as a line segment passing through the focus. Now, how will we know how many units are we going to move to the left and to the right of the focus? The measurement would be 2 times p or 2p units from the focus. So again, starting from the focus, we count 2p units to the left and to the right. Now, the endpoints of the latus rectum will have a notation of LR sub 1 like this and LR sub 2. The labeling of the endpoints of the latus rectum are interchangeable. So it's up to you where would you like to label LR sub 1 and LR sub 2. Now, if you notice, the focus and the endpoints of the latus rectum are aligned. And for you to check if you are graphing correctly, you always need to take note that the focus and the endpoints of the latus rectum are always aligned. After that, we now plot the axis of symmetry. So to plot the axis of symmetry, we simply need to draw a line connecting the focus and the vertex. So we have here the focus and the vertex. Simply draw a vertical line. Now, if the parabola opens upward, the axis of symmetry is a vertical line, whereas the directrix is a horizontal line. So at this point, we are now done illustrating the 5 essential parts of a parabola. The last step in graphing a parabola is to draw the curve. To draw the curve, we are simply going to connect the endpoints of the latus rectum and the vertex. Then in drawing the curve, do not forget to include arrow points so that will have an indicator that both ends of the curves will be extending infinitely in both directions. Let me now highlight the purpose of the latus rectum here. So latus rectum is the line segment from LR sub 2 to LR sub 1 passing through the focus. Latus rectum is one of the most important parts of a parabola because it defines the wideness of the parabola. Let me again illustrate the parts of a parabola, but this time by graphing a parabola that opens downward. So again, the starting point is the vertex, and that will be represented by HK. So say for example, in this parabola, the vertex will be plotted somewhere here along the first quadrant. That will be labeled then as HK. After plotting the vertex, the next point to be plotted is focus. So similar to the previous example, take note that in plotting the focus, you should follow the direction of the opening of the parabola. So since this is a parabola that opens downward, the focus will also be plotted downward. And how many units are we going to move below? That is P units below. So starting from the vertex, we will simply count P units below, and then we plot the focus. After plotting the focus, the next part of a parabola that we're going to plot is the directrix. Now, again, just like a while ago, the directrix follows an opposite direction to the opening. So if it is a parabola that opens downward, in plotting the directrix, the direction will now be going upwards. And how many units are we going to move above? Similar to the measurement of focus, that is P units above. So starting from the vertex, we count P units above, then draw again a horizontal line. The green horizontal line here now represents the directrix. The next part to be plotted are the endpoints of the latus rectum. So in plotting the endpoints of the latus rectum, it's the same with a parabola that opens upward. The movement from the focus will be to the left and to the right. And how many units? That will be 2p units. Again, let me emphasize that when you plot the endpoints of the latus rectum, you always start from the focus because latus rectum is defined as a line segment passing through the focus. So starting from the focus, let us count 2p units to the left and to the right, then label the endpoints as LR sub 1 and LR sub 2. So take note that the focus and the endpoints of the latus rectum are always aligned. So let's check if they are aligned. Yes, they are. So after plotting the latus rectum, we can now graph the axis of symmetry, and we simply draw a line connecting the focus and the vertex. And this is still a vertical line because when you draw a line or connect the points of vertex and focus, you will be able to graph a vertical line. The blue broken lines now here represent the axis of symmetry. After plotting all the essential parts, we now draw the curve by connecting LR sub 1, the vertex, and LR sub 2, and simply including arrowheads to the graph so that we know that it will extend infinitely on both directions. Let me now illustrate the parts of a parabola, by this time graphing a parabola that opens to the right. Again, just like the previous two examples, so we start by plotting first the vertex, and say for example, in this parabola, the vertex is graphed or plotted somewhere here. Then that is labeled as HK. After plotting the vertex, the next is the focus. And since this is a parabola that opens to the right, when we plot the focus, we're also going to move P units to the right. So starting from the vertex, we count P units to the right, and there is where we're going to plot the focus. After plotting the focus, we now plot the directrix, and again, this time, in plotting the directrix, it will be the opposite direction of the focus. So since it's a parabola that opens to the right, in graphing the directrix, we now move P units to the left. And this time, for a parabola that opens to the right, the directrix is not anymore a horizontal line, but rather a vertical line. So the green line here represents the directrix. Moving on, after plotting the directrix, we now plot the endpoints of the lattice rectum. This time, since it's a parabola that opens to the right, when we plot the lattice rectum endpoints, the movement starting from the focus will be up and down. And how many units? Again, just like the previous examples, that will be 2p units from the focus. So starting from the focus, we're going to move 2p units above and below. And there is where we're going to plot the endpoints of the lattice rectum. So notice that in this given graph, still the focus and the endpoints of the lattice rectum are aligned, this time in a vertical fashion. After plotting the endpoints of the lattice rectum, next to be plotted is the axis of symmetry. So simply draw a line connecting the vertex and the focus. And since it's a parabola that opens to the right, the axis of symmetry will now become a horizontal line. So the broken line here, which is in color blue, is the axis of symmetry. Then after plotting all the essential parts, simply connect the vertex and the endpoints of the lattice rectum to form a curve, and also do not forget the arrowheads. Now, if you notice, the purpose of the directrix here is to simply denote where the opening of the parabola is. Since it's a parabola that opens to the right, the directrix purpose here is similar to a borderline so that the curve will not go beyond the directrix. Lastly, let's illustrate the parts of a parabola by graphing a parabola that opens to the left. Again, we start by plotting the vertex at HK. So say for example, the vertex is plotted on this portion of the Cartesian plane. Next to be plotted is the focus. So since the opening is to the left, when we plot the focus, the movement is also p units to the left. So starting from the vertex, let us count p units to the left, and there is where we are going to plot the focus. After the focus, next is the directrix, and then we're going to move on the opposite direction, this time p units to the right. And since this is a parabola that opens to the left, the directrix has the same orientation as the one that we have graphed just a while ago in a parabola that opens to the right. So it is a vertical line. Moving on, next to be plotted are the endpoints of the lattice rectum. So starting from the focus, we are now going to move 2p units up and down. So from the focus, let us move 2p units below and 2p units above so that we can plot the endpoints of the lattice rectum labeled as LR sub 1 and LR sub 2. Again, I would like to emphasize that the focus and the endpoints of the lattice rectum should always be aligned. Lastly, let us graph the axis of symmetry by simply connecting the focus and the vertex. This time, it is a horizontal line, similar to the axis of symmetry of a parabola that opens to the right. To finally draw the curve, connect the points, vertex, and the endpoints of the lattice rectum. And that is the representation by graphing of all the essential parts of a parabola. And that concludes today's video. See you again on the next one. Thank you for watching.